Today we'll be finding the sum from 1 to infinity of -1 to the n minus 1 over n. And to start off, we could consider the sum from 1 to infinity of -1 to the n minus 1 times x to the n over n. So this is the power series, but instead we're going to evaluate it from 0 to 1. So we could turn this evaluation into an integral somehow. And to do that, we have to differentiate this term with respect to x. So we could say this is equal to the integral from 0 to 1, the sum from 1 to infinity of -1 to the n minus 1 over n times the derivative with respect to x of x to the n dx. This is equal to the integral from 0 to 1 of the sum from 1 to infinity -1 to the n minus 1 over n times the derivative of this is just nx to the n minus 1 dx. The n's will divide to 1. We're left with the integral from 0 to 1 of the sum from 1 to infinity of -1 raised to the n minus 1 times x to the n minus 1 power dx. But we can rewrite this as the integral from 0 to 1 of the sum from 1 to infinity of -x to the n minus 1 dx. And you can notice that this is a geometric series where a is 1 and r is -x. So you could say that the sum from 1 to infinity of -x raised to n minus 1 is 1 over 1 minus -x, but that's just 1 over 1 plus x. So you could say that the sum from 1 to infinity of -1 raised to n minus 1 over n is just the integral from 0 to 1 of 1 over 1 plus x dx. And that integral evaluates to the natural log of 1 plus x, wherever we value this from 0 to 1. This is equal to the natural log of 1 plus 1 minus the natural log of 1 plus 0, which is equal to the natural log of 2 minus the natural log of 1. But we know the natural log of 1 goes to 0, and we're just left with the natural log of 2. So therefore, the sum from 1 to infinity of -1 raised to the n minus 1 over n, it's also known as the alternating harmonic series, evaluates to the natural log of 2. And this is the final result. Thank you very much for watching.